Hello again! Since my last video on CBP, some time has passed and a lot was improved, so here's a new, more detailed look at CBP. The basic idea is to write down your Minecraft commands inside a text file, which then gets converted by CBP into a schematic. Let's say I have a file called demo.cbp with my program in it. If you don't want to use your console or terminal, here's a simple way to handle this program on Windows. Create a new text file. I'll call it convert.txt. Put the following line in it: java -jar, and then the full path to the CBP jar file, followed by the name of our text file. For me, that's demo.cbp. I also recommend to add a second line with pause. Finally, just rename this from .txt to .bat. From now on, we just need to double-click this to convert the text file into a schematic. Let's also talk about command line arguments. There are two ways you can use them: as an actual argument in the command, for example -print, or alternatively, you can put them in the file you convert. For that to work, you need to start the very first line with /# and follow it up with the desired arguments. Now to the actual language. CBP is organized in groups of command blocks. All command blocks inside a group can be activated at once by a single fill command. So all commands inside a single group are meant to be activated in the same game tick in a very specific order. To create a group, we have to start a line with a colon followed by a name and a shape. The way shapes get defined is a bit odd, so let me explain. There are two basic layouts in CBP. Either you have the redstone blocks that trigger your command blocks arranged in one dimension or two. And for both versions, you have three different orientations on the X, Y or Z axis. On top of that, you have to think of size limits. Instead of a single long line, you may prefer several shorter ones, which in turn need to be arranged next to each other. To define a shape in CBP, we start by setting the basic layout and its orientation, a single letter for one and a pair for 2 dimensions. This is followed by the layout for combining smaller parts of the group in case it needs to be split, and finally we add 3 values to limit sizes. Let's look at an example. When adding commands to this group, which works by simply writing them below its definition, the necessary command blocks will be placed in a line along X. Once we reach a limit of 4 blocks in length, the next command blocks will start in a new line above the original one. When this line reaches a length of 4 blocks, we not only hit the limit for X, but with 2 lines above each other, also the limit for Y. So we start the next line at the original height, but moved sideways on Z. And since the value of 0 means no limit at all, this can go on indefinitely. I recommend you choose your own favorite configuration and stick with that for everything you do. As you've seen in the example, adding commands works by just writing them in a text file, which I personally find pretty useful already. But of course, CBP can do more. How about we talk about Scoreboard related features? These are selectors that only target players with specific scores. And these are the shorter versions that you can use in CBP. What about setting and changing scores? All you need is a name or selector, the objective you want to change, an operation and a value. In its most simplistic form, these operations set, add or remove a constant value. The more interesting ones require a second entity, real or fake. The system will translate that into an execute that performs a scoreboard command. Of course, the selector for that can be changed with a command line argument. If you use an actual number for these advanced operations, CBP will use a fake entity with the name and value of that number in an objective called const. These fake entities, as well as all objectives and teams you use in your whole program, will be tracked and put inside a special group of command blocks that is created by CBP itself. This group will, when activated, reset or create all the Scoreboard features you need for your program. Now let's have a look at execute. Basically, all you need is a selector in front of your command. Depending on your needs, you then can add coordinates to it, as well as a block ID, optionally with data value and coordinates for using the detect option. Before we dive into the more language-specific parts of CBP, we have to talk again about command block groups. When using just a name and the keyword delay instead of a shape, you create a group that uses falling sand inside Cobweb to serve as a delay or slow clock. These groups can only hold up to 5 command blocks, so they are best used as a trigger for another normal group. To effectively use them, you need a special summon command that takes the name of the group and the amount of delay in game ticks. Similar to this, you can use a special fill command to trigger both kinds of groups. For that you need again the name of the target group, the block you want to place in it, and the block you want to replace with it. Now to the more specific parts. First, define. With it, you set up a single word to be a stand-in for something else. That can also use parameters to make it more dynamic. Import. With this, you can signal the program that you want to include the content of another text file at the position of the import. Functions. They are like a mixture of define and import. Like with import, you can tell CBP to use code that is written down somewhere else. And like with define, you can add parameters. It's important to know that functions store the context, things like existing definitions, of where you define them and use that by default. With the keyword global, you force the function to use the current context. Loop. A loop will repeat the same lines of code over and over, but in each iteration its parameters will be different. They can count numbers up or down, or cycle through a list. When using several counters, the loop will continue until all of them are finished. If at some point you combine, for example, 2 loops, you can add a second number to the parameters to specify from which you want to get the value. Set. Basically just another name for define. But other than with define, existing definitions and parameters are allowed to change the name and value. If. A simple condition that disables one or more lines of code. All numbers except 0 are true, and all text except true is false. Use. This will simply put the given value in front of every line that follows. Built-in functions. CBP has a lot of built-in functions that, from your perspective, will look and work like definitions. Most of them are math-related and shouldn't be hard to recognize. So let me explain the more interesting ones. Int can read numbers in different formats and convert them into a simple integer. NBT-set takes a working NBT string, a value and a key to create a new NBT string with that value inside. NBT-remove works similar, only it removes the key. Escape simply puts a backslash in front of every quotation mark and backslash in the given text, which again is useful for NBT strings. And finally, groupval, which can only be used in lines that are actually meant to be put inside a command block, not in things like loop or if. Its purpose is to give you the properties of a specific command block group, currently only its position inside the schematic and its size. What else is there in CBP you need to know? Well, there is, for example, the option to use a colon and a name to add commands to any group that has a full definition somewhere in your program. This is especially useful for the reset group that is created by CBP itself. I also didn't mention that you can force groups to have a specific location inside your schematic by just adding the coordinates in their definition. Talking about schematic and coordinates, let's say you want to summon an armor stand somewhere relative to the schematic's origin, or do something else that takes relative coordinates. You can do that by just adding the letters X, Y, or Z. CBP will then just add the difference between the schematic's origin and the command block's position in it. You can do the same with absolute coordinates, but for that to work properly, you need to specify the base coordinates using a command line argument. They are the absolute coordinates of the schematic's origin inside a world and are set to 0, 0, 0 by default. Knowing these coordinates also opens up two other possibilities. The first one is using absolute coordinates for the special fill and summit commands that trigger groups. Just add the keyword abs to them. The second one is uploading the schematic directly onto a server using a remote console. Of course, for that to work, Archon needs to be enabled on the server, and you need to set IP, port and password using a command line argument. Essentially, the schematic is broken down into a series of fill and mostly set block commands that build the whole structure. Which brings us to the possible outputs, which you can change using a command line argument. By default, CBP will generate a standard Minecraft schematic file, as well as a conversion output, the one you see when using -print. The other two possibilities are a rather useless list of all blocks used in the schematic, originally intended for a mod or plugin, and a list of all commands that would be sent to a server when using Archon, with the only difference being that it lists even those commands that are too long for a remote console. And that is it. Everything I talked about so far is also in the README you get with the download, so if necessary, you can look up things in there as well. I know, some people want to know how I set up my editor to work with CBP, especially the syntax highlighting. As soon as I figure out how I managed to set this up without breaking anything, I'll make another video and link it right here in this one as well as in the description. If it's not there yet, it will come. Thanks for watching, see you next time.